Hello my dear students, my name is Neha Yadav and I am assistant professor in Noida Institute of Engineering and Technology, Pharmacy Institute, Greater Noida. Today I am going to discuss on the topic that is dipole moment from our subject, that is Physical Pharmaceutics 1, belonging to the code BP302T. Okay. So, in this I would like to remind you few things which we already discussed in our earlier classes. Like we already discussed the dielectric constant, okay, as well as the optical rotation. We have already discussed the optical rotation in our previous class. What is optical rotation? How do we find optical rotation? Application of optical rotation. We have already taken the example of lactic acid and already solved one question to identify the concentration of aniline in a compound to find out the optical rotation. Okay. So, as already we discussed the dielectric constant, how to find the dielectric constant, there we have already discussed a topic, means like a definition kind of a thing on dipole as well as dipole moment. So, in dielectric constant what we have, we already discussed how to identify the dielectric constant in our liquids, okay, in our solids, what are the application of these dielectric constant and what are the precautionary measures which we have to take in consideration to calculate the dielectric constant. Okay. In dielectric constant what we have two parallel plates in which they are separated by an insulating medium, okay, which is responsible to differentiate the two parallel plates, and the medium having any kind of charge, like if it is having positive charge, then the deposition of positive ion on the upper plate. If it is having negative charge, then the deposition of negative ions on the magnetic plates. So, today in my class we are moving to our next topic and we discuss broadly that dipole moment. What is dipole moment? Dipole moment hota kya hai? It is a very important topic because there are very questions or examples, there are lots of questions to calculate or identify the dipole moments of a particular compound. A compound is given to you, okay, and we can ask that identify the dipole moment of that particular compound. So, first thing in dipole moment you have to take in consideration is that if a compound is equals to 0, okay, then it will be non-polar in the nature, means if the dipole moment of a compound is equals to 0, then it is non-polar in the nature, okay. Example, we have chlorine, okay, like the charge, positive and negative charge on both the sides are equal. Next we have that, we can say that is homoatoms, okay. Next we have heteroatoms. In heteroatoms we can take the example of carbon dioxides, okay. In carbon dioxide what we have, like here the dipole moment of carbon dioxide is not equals to 0, then it is termed as an polar compound. So, with this I would like to move forward with the introduction of our dipole moment. So, in the chemical structure of a polar molecule, the poles are separated. The phenomenon is pictorially represented as follow. That means, here one diagram is already mentioned which is containing some charges. A molecule is there and a dipole molecule is there. And this is a molecule as a whole. A molecule as a whole, it is a neutral molecule. You can say it is having a positive and a negative charge. Now, here charge is separated in the form of a dipolar molecule. Positive charge is on one hand and the negative charge is on other hand. In my previous class, I have already discussed about the dipole. तो डाइपोल क्या था हमारा? डाइपोल में था द पॉजिटिव आयन, ओके, द what do you mean by in dipole? In our previous class we discussed that dipole is the positive ion and in the other hand the negative ions, when they are separated with a small difference, is known as the dipole. So, here the positive ion is on the one side and the negative ions on the next side, and they both are separated with very less difference, then it is known as dipole, and the moment in these molecules is known as dipolar molecular movement. This is uneven charge distribution. Okay. So, this uneven charge distribution can be happen only on the types of the compound. So, here we can say the molecules, when it is whole in neutral, it has positive and negative charge connected, but when we separate, positive comes to the one end and the negative goes to the next end, and the difference between positive and negative is very less. It is known as dipole, and that reason is known as the dipolar molecular uneven charge distribution. Okay. The dipolar molecule is defined as the one in which the region of the positive and negative charge are well separated due to uneven distribution of the electrons. Okay. Although a molecule is separated by the presence of regions of positive and negative charges, these are balanced. अगर कोई भी हमारे पास एक ऐसा मॉलिक्यूल है जिसको अगर हम रिप्रेजेंट करना चाहते हैं बाय द प्रेजेंस ऑफ रीजन ऑफ पॉजिटिव एंड द नेगेटिव चार्ज, देन द चार्ज शुड बी बैलेंस्ड. ओके. दस द मॉलिक्यूल एज अ होल डज नॉट पॉजेस चार्ज. तो वो कंप्लीट मॉलिक्यूल है, वो कोई चार्ज को पॉजेस नहीं करता है. चार्ज सेपरेशन इन अ मॉलिक्यूल शुड बी व्यूड विदाउट द इन्फ्लुएंस ऑफ इलेक्ट्रिक फील्ड एंड अदर इंड्यूस्ड इफेक्ट. तो जो चार्ज सेपरेशन होता है हमारे मॉलिक्यूल्स का, उसको अगर हम देखना चाहें तो कैसे देख सकते हैं? विद द हेल्प ऑफ इन्फ्लुएंस ऑफ द इलेक्ट्रिक फील्ड एंड अदर इंड्यूस्ड इफेक्ट्स. ओके. एग्जाम्पल ऑफ डाइपोल मॉलिक्यूल वी कैन कंसिडर वाटर, हाइड्रोक्लोरिक एसिड एक्सेट्रा. ओके. इन वाटर, oxygen is an electronegative atom that has a greater tendency to draw the sharp pair of electron towards it. तो अगर हम ऑक्सीजन एग्जाम्पल की बात करते हैं, अगर वी हैव टेकन वन एग्जाम्पल फ्रॉम बोथ ऑफ द एग्जाम्पल दैट इज वाटर एंड हाइड्रोक्लोरिक एसिड, एंड इफ वी टॉक अबाउट द वाटर, तो उसमें होगा क्या? जो वाटर में ऑक्सीजन जो है वो हमारी इलेक्ट्रोनेगेटिव एटम है, और उसकी ज़्यादा टेंडेंसी है कि वो एक शार्प पेयर इलेक्ट्रॉन का अपनी तरफ खींचेगी. ठीक है. तो एज अ रिजल्ट हाइड्रोजन एटम्स जो हैं वो एज्यूम कर लेंगे एक पॉजिटिव चार्ज एज द शेयर्ड इलेक्ट्रॉन पेयर इज ऑलवेज फ्रॉम इट. वो एक इलेक्ट्रॉन पेयर को वहाँ से शेयर कर लेंगे. ठीक है. दस द पॉजिटिव एंड नेगेटिव सेंटर्स आर डेवलप्ड इन अ मॉलिक्यूल. इसी हिसाब से क्या होता है, आपके किसी भी एक मॉलिक्यूल में पॉजिटिव और नेगेटिव सेंटर्स जो हैं वो डेवलप कर जाते हैं. बाय द कन्वेंशनल चार्ज सेपरेशन इज रिप्रेजेंटेड एज एन एरो ड्रॉन पॉइंटिंग फ्रॉम अ पॉजिटिव एटम टू अ नेगेटिव एटम. अगर हम एक कन्वेंशनल चार्ज सेपरेशन की बात करें तो हम उसमें क्या एक एरो से उसको डिनोट करते हैं फ्रॉम नेगेटिव टू पॉजिटिव. द एरो इंडिकेटिंग is from to the positive and the arrow which starts is from the negative atom. Few examples are also listed in this diagram. The first example we have dipole moment general description. General description है हमारे पास dipole moment की. आप यहीं से जो हम पढ़ रहे थे, by conventional charge separation is represented as a arrow drawn. Okay, pointing from the positive atom to a negative atom. Here it is the positive atom. Okay, from this positive atom the arrow is drawn towards the negative atom. So this is the dipole moment general description. General description में हम कैसे बताते हैं कि arrow जो है हमारा पॉजिटिव से नेगेटिव की तरफ ड्रॉ किया जाएगा. ठीक है. नेक्स्ट वी हैव हियर H and F. Mu is equals to 1.75, that is hydrogen and the fluoride. This is your hydrogen, this is your fluoride, and if mu is equals to 1.75 D. Next we have mu is equals to OD, that is methane. Okay. Next we have carbon tetrachloride. Okay. So, here in carbon tetrachloride what we have? Carbon, and we have 4 chloride attached to it. This from carbon to chloride, carbon to chloride, carbon to chloride, carbon to chloride. So, this is the kind of the conventional charge separation which is represented by a arrow, which is always drawn from pointing from a positive atom to a negative atom. Okay. So, moving to the next, we have dipole moment of a polar covalent compound. Now, we are going to discuss about the dipole moment of polar covalent compounds. Here first we have, when a bond is formed between two dissimilar atoms, if the atoms are not similar to each other and the bond is formed between these two atoms. Okay. So, the bond which is formed between two dissimilar atoms, then more electronegative element become more electron rich, whereas the less electronegative elements become electron deficient, resulting a polar covalent bond. When it comes to polar covalent bond, when your pi bond is not equals to 0, यही मैंने आपको स्टार्टिंग में ही बताया कि if our dipole moment of a compound is equals to 0, then that compound is non-polar. And if the dipole moment of any compound is not equals to 0, then it is polar in the nature. So, with this we have, when एक बॉन्ड जो है हमारा दो डिसिमिलर एटम्स के बीच में फॉर्म होना शुरू करता है, ठीक है, दो सिमिलर एटम्स नहीं है, उनके बीच में एक बॉन्ड फॉर्म हो गया, देन मोर इलेक्ट्रोनेगेटिव एलिमेंट बिकम मोर इलेक्ट्रॉन रिच. तो जितने ज़्यादा उसमें इलेक्ट्रोनेगेटिव एलिमेंट्स होंगे वो उतने इलेक्ट्रोनेगेटिव एटम्स को अपनी तरफ खींच लेंगे और वो रिच हो जाएंगे इन इलेक्ट्रोनेगेटिविटी. वेयर एज लेस इलेक्ट्रोनेगेटिव एलिमेंट्स जो होंगे वो क्या हो जाएंगे, उनका इलेक्ट्रॉन का डेफिशिएंसी हो जाएगा, विच रिजल्ट्स एज एन पोलर कोवेलेंट बॉन्डिंग, बिकॉज जो इलेक्ट्रोनेगेटिव एटम्स हैं वो मैच करेंगे इलेक्ट्रॉन्स को, वो उसको गेन करता चला जाएगा और रिच होता चला जाएगा. ठीक है. द डाइपोल मोमेंट ऑफ अ पोलर बॉन्ड इज नॉन जीरो एंड इट्स रिप्रेजेंटेड एज पाई बॉन्ड दैट इज नॉट इक्वल्स टू जीरो. द डाइपोल मोमेंट ऑफ पोलर मॉलिक्यूल इज non-zero. Okay. So, here we can say dipole moment of non-polar covalent bonds. When a bond ID formed between two similar atoms with similar electronegativity, then bond pair of electron is equally attracted by both the atoms. As a result, what happens? The atom become neutral in their nature. Okay. Such a bond formed is non-polar covalent bond. That bond which formed after the neutral atom, that bond is known as non-polar covalent bond. The dipole moment in the non-polar bond is 0 and it is represented as pi bond that is equals to 0. Okay. So, जब डाइपोल मोमेंट हमारी किसी भी कंपाउंड की इक्वल टू 0 होती है तो दैट कंपाउंड इज नॉन पोलर इन द नेचर. द रिजल्टेंट डाइपोल मोमेंट ऑफ अ नॉन पोलर मॉलिक्यूल इज 0. इट इज रिप्रेजेंटेड एज मॉलिक्यूल इक्वल्स टू 0. ओके. तो जो डाइपोल मोमेंट अगर 0 होगी तो वो मॉलिक्यूल भी क्या होगा आपका, उसका डाइपोल मोमेंट 0 हो जाएगा. Mathematically, if you would say, mathematically if we can say and calculate the dipole moment, the treatment is mentioned here as the magnitude of charge separation is expressed as a dipole moment. कितने magnitude में charge का separation हो रहा है in the form of positive and the form of negative, it expressed as the dipole moment. तो जो पॉजिटिव चार्ज एक तरफ कनेक्टेड हो जाते हैं, नेगेटिव एक तरफ कनेक्ट हो जाते हैं, द मैग्नीट्यूड ऑफ सेपरेशन ऑफ चार्जेस, it produces the dipole moment, it expresses the dipole moments. So the dipole moment is defined as the vector, okay, which is equal in magnitude to the product of electric charge and distance. तो इसमें दो चीज़ें हो जाती हैं कि आपका जो प्रोडक्ट है उसकी क्वांटिटी कितनी है एज वेल एज दी डिस्टेंस कितना है. फॉर एग्जाम्पल इफ वी से इफ वी हैव अ कंपाउंड Q, ठीक है, दिस इज अनदर कंपाउंड Q, इन दोनों पे चार्ज का मैग्नीट्यूड कितना है, ठीक है, एज वेल एज इन दोनों के बीच का डिस्टेंस कितना है. दिस विल गिव यू द मैग्नीट्यूड चार्ज सेपरेशन ऑफ अ कंपाउंड. द डाइपोल मोमेंट इज डिफाइंड एज द वेक्टर इक्वल इन मैग्नीट्यूड टू द प्रोडक्ट ऑफ इलेक्ट्रिक चार्ज एंड द डिस्टेंस. की ये दोनों जो चार्जेस हैं इनका प्रोडक्ट कितना होगा प्लस इन दोनों के बीच में डिफरेंस कितना है. This will give the direction of the line joining to the positive and negative centers, and you know it always starts from the positive and goes to the negative. Okay, mathematically we can express the dipole moment in the form, dipole moment can be written in the form of mu. Okay, dipole moment is equals to distance into the charge. What is the distance? That is multiplied to the charge ratio. Okay, so here distance is defined by the mu. Distance, dipole moment is defined by the mu, distance is defined by r, and the charge is by E. We can also know the SI units of the following. Dipole moment, that is mu, SI unit is centimeter. Okay, distance की जो SI unit होगी वो हमारी मीटर में होगी और चार्ज की जो होगी वो हमारी होगी कॉलम में. ठीक है, चार्ज कैन बी एक्सप्रेस्ड इन द फॉर्म ऑफ E and it is mentioned in the form of SI unit is column. Okay. So, in our CGS system the unit is dBi. Okay, 1 dBi unit is equal to 3.336 into 10 to the power minus 30 column into meter, that is centimeter. Okay, that cm is equals to column meter, that cm which mentioned here it is column meter. Okay, dipole moment indicates the refractive polarities of different molecules. तो dipole moment क्या indicate करता है, different molecules की refractive polarities को, कौन सा molecule किस हिसाब की refractive polarities show करेगा, it will be identified by the dipole moments. A molecule may contain many bonds. Okay, each bond is considered separately and finally summed up. हर जो मॉलिक्यूल्स हैं इसमें उन सब में क्या होगा, बहुत सारे अलग अलग बॉन्ड्स होंगे और ये जो बॉन्ड्स होंगे इनको हम क्या करते हैं, बॉन्ड इज कंसिडर्ड सेपरेटली, सब बॉन्ड्स को हम अलग अलग तरीके से लेते हैं और फाइनली इन सबको हम एक साथ समड अप कर लेते हैं. ठीक है, एड अप कर लेते हैं. इट इज़ नेसेसरी टू इंक्लूड बॉन्ड्स विथ लोन पेयर ऑफ इलेक्ट्रॉन्स ऑल्सो. इट इज़ नेसेसरी टू इंडिकेट. ओके, इसमें ज़रूरी क्या है कि हमको बॉन्ड्स को भी इंक्लूड करना है जिसमें उनके साथ के लोन पेयर्स भी होने चाहिए. ठीक है, एंड जो देन उसके बाद ही हम कैलकुलेट कर पाएंगे नेट डाइपोल मोमेंट. ओके, व्हेन जब हम इसमें जितने भी बॉन्ड्स हैं विद देयर लोन पेयर ऑफ इलेक्ट्रॉन्स उनको भी ले लेंगे. ठीक है, सारे बॉन्ड्स को ले लेंगे, उन सबको समड अप कर लेंगे, देन ओनली वी कैन आइडेंटिफाई और वी कैन एस्टिमेट द डाइपोल मोमेंट, net dipole moment of a particular compound. So, this is represented for the following compounds. Here few compounds are mentioned, like first we have ammonia, second we have water, third we have nitrogen trifluoride. Okay, so we'll talk about one by one. In ammonia, what happened, dipole moment is equals to 1.46 D. Okay, so what does happens in the ammonia case, this in the ion, the arrows are indicating from this positive to the negative charge, right? All the arrows are moving to same direction and the arrow always moved like this. Here the positive moving to the negative ion. Next we have water. The dipole moment of the water is 1.84 d. Here again this is the positive ion moving to the negative water ion. Next we have dipole moment of nitrogen trifluoride, that is 0.24 d. Here molecules are moving from the positive nitrogen ion to the negative fluoride ions. Okay, clear? So, here some of the dipole moments of few compound are listed in this table. Okay. Here number of the solvents which I have taken is 6 and the solvents are benzene, methanol, ethanol, water, chloroform and acetone, and the dipole moment is mention of these all compounds in the Debye units, and you can see these are listed in the form of increasing order. Okay. From 0 it is increasing to the maximum order. So, benzene have 0. Okay. When a dipole moment of a compound is equals to 0, then that compound is what? It is non-polar compound, right? This was we have studied in our previous slide ना कि dipole moment अगर किसी भी compound का 0 होगा then it is non-polar in nature. If dipole moment is not equals to 0 then it is polar in the nature. So, we can say methanol is non-polar in nature, it is non-polar in nature, right. Next we have methanol. Methanol, the dipole moment is 1.69, ethanol is 1.70, water is 1.84, okay, chloroform 1.86, acetone that is 2.88. So, these are some solvents which have the dipole moments in the unit Debye is listed in this table. Moving to the next, we have dipole moments of some compounds. Okay. There we have discussed about the solvents, now we are discussing about the drugs. Differences, here we are discussing about the drugs and their dipole moments. In the previous table we discussed the solvent with their dipole moments. So, here also I have taken 6 example of the drugs, and the first drug is phenobarbital, cholesterol, aspirin, testosterone, sulfanilamide and androsterone. Okay. So, we will talk about one by one. The dipole moment in the Debye unit of first drug, that is phenobarbital, is 1.16. Okay. Cholesterol it have 1.99, aspirin it has 2.07, testosterone it is 4.32, sulfanilamide it is 5.37, androsterone it is 3.70. Clear? So, this is some dipole moment of the drug compounds. Now, we have the application of dipole moments. What are the application of dipole moments? The first application is solubilization of drugs, means the application of dipole moment in the solubility of a drug. When a solute is added to a solvent such as water, the permanent dipoles of water strongly interact with the solute, and this type of interaction enhance the solubility of solute in a variety of ways. Okay. So, 2 ways are already mentioned here. The first is by hydrating the solute molecules and the ion. What it will do? It hydrates the solid molecules and the ions. Another by indicating dipoles in the non-polar molecule. What it do? It indicates the dipole in the non-polar molecules. Some solutes are symmetric and planar. What is symmetric? Which have mirror image. Okay. तो कुछ solutes क्या है हमारे symmetric हैं and planar हैं. Next application is crystalline nature of the solids. If a solid is of crystalline nature, then solids are polar molecule. The dipole moments contributes to the orientation of molecule in the solution. The same arrangement will be subsequently incorporated into the crystal lattice of the solids. For example, if we talk about ice crystals and organized through their dipole forces. Okay. Moving to the next application, we have drug receptor interaction. the dipole forces are believed to contribute the interaction of drug with the receptor. Okay. The dipole moment believe that the drug interacts with the receptor with the help of the dipole moment only. Next, therapeutical activity of the drug. Likewise, permanent dipole moment can be correlated with the biological activity. For example, we have insecticidal activity of DDT can be correlated with the structural requirements. Okay. Next application is chemical structure of the compounds. What are the chemical structure of the compound? How it helps in that? Dipole moment of a substance provide valuable information regarding the structure of a molecule. Few examples are already illustrated here. First is deciding ion nature of the bond hydrochloric acid, okay. Identifying the shape of the molecule oxygen like carbon dioxide. Next, identifying the shape and bond angle, we have example that is water. Then deciding the arrangement of groups, for example dichlorobenzene, and lastly identification of geometric isomers, we have dichloroethane. So, these are the chemical structure compounds with the arrangements and with examples. Okay. Moving to the next, induced polarizability, induced dipole moment. Induced polarizability is a characteristic of a molecule. It depends not only on the external field, but also on the compound that has the ability to get polarized. Okay. So, polarizability, it is defined as the ease which will an ion or a molecule can be polarized by any external force. The external force may be an electrical field, okay. It can be either a light energy or another molecule. So, in the influence of electrical field, dipole can also have induced dipoles which facilitate further alignment of negatively charged centers. Similarly, chlorine molecule get polarized and develop charge. This is also called induced dipole moment. Fine. This is also known as induced dipole moment. Like क्लोरीन मॉलिक्यूल जब पोलराइज कर दिए जाते हैं और वो क्या करते हैं, एक चार्ज डेवलप करते हैं, वो जो चार्ज होता है उसको हम क्या बोलते हैं, इंड्यूस्ड डाइपोल मोमेंट. Likewise, these are the references from where I have taken my all the content for the presentation. So, with this I would like to conclude my this lecture, okay, and in this we have discussed about the whole dipole moment, the calculation, application, measurement of the dipole moments. So, finally, I would like to conclude. Thank you and have a good day.